Hello students, let us continue our chapter Complex Number and Quadratic Equations. In our previous class, we have solved exercise 5.1 and today we will study about Argand plane and polar representation. Now see, we already know that corresponding to each ordered pair of real numbers xy, okay, we get a unique point in the xy plane. This is our x and this is our y plane. This one that we know that, okay. Now and vice versa with reference to a set of mutually perpendicular lines known as the x-axis and the y-axis. The complex number x plus iy. The complex number x plus iy, okay, which corresponds to the ordered pair of xy can be represented geometrically as the unique point pxy in the xy plane and vice versa. Just you see some examples of such numbers, just like 2 plus 4i, okay, then other you can say 2 plus 3i, then 0 plus 1i, then minus 5 minus 2i and 1 minus 2i, which corresponds to the ordered pair, 2, 4. Okay, then minus 2, 3, 0, 1, 2, 0. After that, minus 5 minus 2 and 1 minus 2 respectively have been represented geometrically. Here it have been represented geometrically as the points A, B, C, D, E and F respectively. So the plane having a complex number assigned to each of its point. I am repeating, the plane having a complex number assigned to each of its point is called the complex plane or the Argand plane. Okay. So we can say that the plane having a complex number assigned to each of its points is called the complex plane or the Argand plane. And in the Argand plane, the modulus of the complex number, okay, in the Argand plane, the modulus of the complex number x plus iy is equals to root under x square plus y square. So this one x plus iy is equals to root under x square plus y square. Okay, is the distance between the point pxy to the origin O, origin 0, 0. So the points on the x-axis corresponds to the complex number of the form a plus I0. Okay, the point on the x-axis corresponds to the complex numbers of the form a plus I0. And the point on the y-axis corresponds to the complex number of the form 0 plus IB. Okay, and the x-axis and the y-axis in the Argand plane are called respectively the real axis and the imaginary axis. So we can say that the x-axis and the y-axis in the Argand plane are respectively the real axis and the what? Imaginary axis. And the representation of the complex number z is equals to x plus iy and its conjugate z is equals to x minus iy in the Argand plane are respectively the point pxy and qx minus y. So geometrically the point x minus y is the mirror image of the point xy on the real axis like this. So it will be like this, pxy and qx minus y. So we can say that the point x minus y is the mirror image of the point xy on the real axis. And in the next class, we will study about the polar representation of a complex number. So this much for this class and rest in the next class. Till then, have a good day.